So what is the effect of averaging on our measurement uncertainty? As we mentioned, if we give a counter more time to do this averaging, we will reduce our measurement uncertainty. And we can do the same with the cycle basis. So we can say, I want to average not over a half cycle, but over 4, for example, which I did here. Nice thing is, as we have all our raw data, we can change this afterwards. So we can say, I want to have a look at our dynamic signal, like we did over here for the mechanical bit, for example. Or I can have a look at cycle synchronous data to analyze what happens to the input of my inverter when I do a load step on the electrical machine. And we even can change this averaging period online. So what I did here is I created a few simple user keys in Perception. And all this does is update my formula in our formula database I've shown earlier. So let's say we go into inverter analysis, expand them all. And here we see I have this cycle count in variable, and that's the one I'm changing using those user keys. And that's the value being used in the rest of my formulas to give you a bit of a peek behind the screens of what I'm doing. So if I now change my cycle count, which is currently 4 to 2, for example, we instantly see our calculation rate is updating, and we see more dynamics in our signals. So we can even go back to 1 cycle based, or the most dynamic power measurement of a half a cycle. And in that case, again, we see the dynamic behavior of the machine coming back in. We see the machine going from generator to motor, from generator to motor. So we see some efficiencies over 100%. But as we know how our system is calculating this, we can understand it.